So now we have understood that what exactly log of odds ratio is. Okay. Now guys, in order to understand your logistic regression, again, as your linear regression has a definition, similarly logistic regression has also a definition which says logistic regression is a process of establishing relationship between dependent and independent variable by estimating its underlying logit function. Okay, by estimating its underlying logit function, probabilities of logit function, to be honest. Okay, so let's see what exactly this logit function is. How do we derive this logit function? So again, let's use a scenario. If I give you an example, so we have a graph here. Now this graph talks about the categorical data. Okay, a binary categorical data. Let's say about diabetes. Okay, whether the given patients have diabetes or not on given age. Okay, given the age, we need to figure out whether the patients have diabetes or not. Right. So there, sorry, not age, weight. So weight at x-axis. Weight is an input at x-axis, and at y-axis we will be predicting diabetes. Okay? We will be predicting diabetes, whether the patient has diabetes or not. So the value will be 1 for diabetes, yes, and the value will be 0 for no. Okay, so guys, we all know when it comes to diabetes, uh, if your weight increases, the chance of getting diabetic increases, right? The chance of getting diabetes increases. If you increase your weight, there is a possibility that you might get end up with diabetes, right? So what we are going to do is, let's suppose there are certain observation here with uh, with less weight. Okay, there is one observation here, and there is one observation over here, one over here, one observation here, right? Similarly, when it comes to people who have diabetes, definitely the age will be more. So let's say there is one observation over here, because as you can see, as you are increasing toward the direction, toward the right hand side, the age is increasing. So if the age increases, the chances of getting diabetes increases. So this is also have diabetes. This patient also have diabetes. This patient also have diabetes. Let's say. Okay, so there are some people who have diabetes, there are some people who don't have diabetes, right? Now when it comes to your linear regression, guys, okay, when it comes to your linear regression, in linear regression you get a regression line, right? In linear regression you get a regression line for your inputs. Okay, in linear regression you get a regression line for your inputs. Okay, now if you see, this regression line is not at all fitting your data properly, right? This regression line is not at all fitting your data properly. Also, as you can see the y-axis, right? As you can see the your target variable here, the target variable should always be 0 and 1. But if you consider the interpretation, if the value of x is this, definitely the value of y will lie between 0 and 1. But as you go ahead over x, right, the value of y will go beyond your value of 1, beyond your range, right? So this is a problem, right? This is a problem because we have only two outputs, that is 0 or 1. Output cannot go beyond your 0 and 1 range. But we all know when it comes to the line of regression, it lies the range, I mean the range lies between minus infinity to plus infinity. Line of regression gives you the range of minus infinity to plus infinity, guys. Okay, that is regression line. So this is the range. So we don't want that, guys, because as we all know, the output for this particular case study of whether the patient will be diabetic or not, the output will be only two, that is 0 and 1. So we don't want our value beyond 0 and 1, beyond the range of 0 and 1. Okay. So what we are going to do is we will be manipulating this formula, sorry, we will be manipulating this line so that it can work as per our situation. Okay, we need to limit this range of regression line between 0 and 1. Again I repeat, we need to limit the range of regression line so that it could give the value between the range of 0 and 1. Okay, we don't want the range of minus infinity to plus infinity. Okay, we are here about to solve the classification problem. Okay, so we need to limit the range, the value of this regression line. So how to do that, guys? What is the equation, what is the formula by which we got this line? We got this using the equation of y is equals to mx plus c, right? We got this by using the equation of y is equals to mx plus c, right? Now as you can see over here, the line of regression has the range of minus infinity to plus infinity. Do you feel any common point between line of regression and odds ratio range? Yes. Odds ratio also has the common range of minus infinity to plus infinity. So here what I'm going to do is I'm going to equate this line of regression and your log of odds ratio, because both have common range, right? So mx plus c is equals to log of odds. Okay, mx plus c is equals to log of odds. So what is odds ratio formula? The formula for odds ratio is p upon 1 minus p. Okay, p upon 1 minus p. This is what the formula of odds ratio. Now what we are going to do is I will remove this log from here. Now in order to remove this log from here, we need to add an exponential term. Okay, we need to add an exponential term in order to remove the log value. So I will be adding the exponential term. So e to the power mx plus c. Okay, e to the power mx plus c. If I do this, the log value will be removed and we will be getting p of, sorry, p by 1 minus p. Okay, we will be getting p by 1 minus p, right? This is what we get. Now after this, what we are going to do is we will be taking the reciprocal on both sides. Okay, we will be taking the reciprocal on both sides. What do you mean by reciprocal? Denominator will become the numerator and numerator will become denominator, right? So this is upon 1, right? We don't write that. So we will be writing, when it comes to reciprocal, we'll be writing it like the denominator was 1, so 1 upon e to the power mx plus c. Okay, mx plus c, e to the power mx plus c is equals to 1 minus p upon p. If you take reciprocal on both sides, this is what the equation would look like, right? So after doing that, what I'm going to do is I will split these terms. Okay, I will split this term. So this will become as it is, right? The left hand side equation will become as it is. So e to the power mx plus c is equals to 1 upon p minus p by p. Okay, so what I'm doing, I'm splitting the denominator. It is said that in mathematics, when the denominator is same, you can merge it. You can write it once. So we are just using the converts of it. We are splitting the denominator because it is same for both. And if you divide, so p ones are p, right? So we will be dividing it like this, and it will become 1 upon e to the power mx plus c, right? E to the power mx plus c is equals to 1 upon p minus 1, 1 upon p minus 1. Okay, so next what I will be doing is I will be taking this minus 1 to that side, basically to the left hand side. Okay, so if I do that, so 1, so the minus will become plus, right? So 1 upon e to the power mx plus c plus 1. Okay, plus 1, and here at right hand side we'll be getting only 1 upon p. Okay, now again what I will do is I will rearrange this equation properly. Okay, I will rearrange this equation. Also I will do cross multiplication. So I will multiply this e to the power mx plus c by 1, and I will multiply this 1 by the denominator over here. So I will do the cross multiplication here. So once I do that, we will be getting the equation like 1 upon e to the power mx plus c 1 upon e to the power mx plus c plus, since we have performed the cross multiplication, we will be multiplying 1 into e to the power mx plus c. All right, and at right hand side it will be 1 by p. Okay, now what I will do is I'll just take the reciprocal once again. All right, I will take reciprocal, or you can say, yeah, I will take the reciprocal once again. So what this will become is, after taking the reciprocal, it will be like e to the power mx plus c, denominator will become numerator, mx plus c upon 1 plus e to the power mx plus c, right, is equals to p, right, is equals to p. Now this equation, guys, I'll let me rearrange this in a proper order. So this is written as p is equals to e to the power mx plus c upon 1 plus e to the power mx plus c. Okay, upon 1 mx plus c. Now this equation is known as This equation here is known as Logit function. Okay, this equation here is known as Logit function. What Logit function does, guys, the regression line that we were getting by using this equation of mx plus c has the range of minus infinity to plus infinity. So what this logic function will do is that will boil down the range of mx plus c to 0 and 1. ओके, ये जो आपका रेंज पहले माइनस इन्फिनिटी से लेकर प्लस इन्फिनिटी तक का था एम एक्स प्लस सी का इक्वेशन यूज करके स्ट्रेट लाइन का फॉर्मूला से, अब लॉजिट फंक्शन इंप्लीमेंट करने के बाद यू विल बी गेटिंग द रेंज ऑफ 0 and 1. Okay, the same line will be converted to the range of 0 and 1. Similar to this, we have one more function which is called as sigmoid function. If you derive ahead, I'm not going to derive that. If you just keep on deriving it ahead, you will be getting the equation like p is equals to 1 upon, okay, p is equals to 1 upon 1 plus e to the power minus mx plus c, e to the power minus mx plus c, and this equation is known as sigmoid function. इस equation को हम sigmoid function बोलते हैं guys, right? It does the same thing for you. It will boil down the range of minus infinity plus infinity to 0 and 1. Okay, this function is known as sigmoid function, right? This function is known as sigmoid function. Okay, now what happened here is, if you do not understand what this exactly this derived, so what happened here is, let me show it to you a graphical view. So this is our graph, right? If you remember, this is the graph that we have drawn. Okay, weight upon, sorry, weight by diabetes. This is the graph that we have drawn, which gives us which gives us the range of minus infinity to plus infinity. If you draw a regression line from this, this will be range from minus infinity to plus infinity, right? This will be range from minus infinity to plus infinity. I don't want that, because we all know, for here, for logistic regression problem, we have binary outputs, that is 0 and 1. I don't want any value that goes beyond this range. So what we have done is, the formula of y is equals to mx plus c, right? The formula of mx plus c has been manipulated. We have implemented the sigmoid function on this formula of mx plus c. Okay, we have implemented the sigmoid function, which is given by 1 upon 1 plus e to the power minus mx plus c. We have converted the equation of line to this particular formula, that is the sigmoid function. Now what will this do? This will bring down the range of infinity to 0 and 1. Okay, this will bring down the range of this infinity to 0 and 1. So what we have done is, we have manipulated this formula of equation of line by using the sigmoid function for getting the range of 0 and 1. So now what will happen is, once you implement this sigmoid function over the equation of line, right? Once you implement this sigmoid function over the equation of line, you will be getting the S-shaped curve, okay, which will definitely give you the range of my 0 and 1. So it doesn't matter what your weight is, your value, the probability value will always lie between 0 and 1. Doesn't matter what your weight is. Okay, so given the weight now, you are able to get the probabilities that what are the chances for yourself of getting diabetic. Not only that, when it comes to logistic regression, guys, logistic regression default set a threshold of 0.5. Okay, logistic regression by default sets a threshold of 0.5. So if the probability value lies above 0.5, the patient will be considered as diabetic. If the probability value lies below 0.5, the patient will be considered as not diabetic. Right? Now, as you can see, both the range of this line after implementing sigmoid function over the values, it gives me the range, it gives me the probability value between 0 and 1. Right? And by using the threshold of 0.5, we can categorize whether this probability or whether the patient belongs to which category, whether it belongs to 0 or whether it belongs to 1. Okay, now to summarize this, what we have done is, if you notice, when it comes to this problem of logistic regression, when it comes to this classification problem, we are not at all able to solve our classification problem using the formula of straight line, because this is not fitting the data properly. Why? Because here y variable gives only two output, that is 0 and 1, and regression line gives you the range of minus infinity to plus infinity. So that is the reason we don't want the output should be beyond our range of 0 and 1. So what we have done is, we have equated, since your regression line range and odds ratio range, log of odds ratio range, both are same. So we have equated it with log of odds ratio. We have equated your regression line and log of odds ratio with each other, and by that we have derived this logit function and sigmoid function, which reduces the range or which brings the value under the range of 0 and 1. And by using that, we are able to interpret that which patient will be diabetic and which patient will not, by using the threshold of 0.5. Okay, so if the probability value lies above 0.5, definitely the patient will be diabetic. If the probability value lies below 0.5, the patient will not be considered as diabetic. Okay, so this is what sigmoid function does. Right, it brings all the probability value between the range of 0 and 1. Okay, for sigmoid function, the y or the output lies between 0 and 1 only. And this is the reason also why it is logistic regression is called as regression. Right, this is also the reason why logistic regression, which is a classification algorithm, called as regression, because we are here starting with a line, we are starting with a straight line. Okay, we are deriving all these logit function and sigmoid function using the formula of straight line. Right, secondly, although we have, I mean, categorized the your y variable here, but unless and until we set the threshold of 0.5, we are getting the probabilities, which can be any continuous number. Right, which can be any continuous number. And if any algorithm is giving you a number, that algorithm will come under regression part. Okay, so unless and until you set the threshold, you are working as a regression problem, you are working on a regression problem. The moment you set the threshold of 0.5, which is set by default in logistic regression, at that time the regression problem becomes the classification problem. Okay, since by default it is working with a continuous number, we call logistic regression as regression, not classifier. Okay, and the second reason, or the first reason, is because we are here starting this equation using the formula of line, a straight line. All right, so this is all about your derivation of logit function. Is there any doubt till here, guys?